all your devices on a network have an IP address. Okay? Your routers and your switches have ports. They have IP addresses associated with them. Okay, so it's going to be important that we understand IP addressing. It's better if my stuff would work. What you should be able to do once you've read Chapter 8 and done the assignments in Chapter 8 is to be able to describe the structure of an IPv4 address. Okay? It is a 32-bit address with 4 octets of 8. Describe the purpose of a subnet mask, and that's important with IPv4. You're going to compare the characteristics and uses of unicast and broadcast and multicast within IPv4 addressing. We're going to explain the need for IPv6 addressing, why it exists, why we need it. Describe the representation of the IPv6 address. Describe the types of IPv6 network addresses and configure global unicast addresses. Okay? IPv4 is set up in binary notation, ones and zeros. Because what does a computer talk in? Ones and zeros. It's a machine. Okay? So our IPv4 address can be represented in binary, or we can convert it to what's called dotted decimal, because us as humans seem to understand and can remember dotted decimal better than we can understand binary. Okay? It's easier to represent and understand 192.165.25.3 instead of 32, a string of 32 ones and zeros. Okay? It just seems to be a little bit easier to understand that way. Converting binary to decimal requires understanding of mathematical basis of numbering systems. Don't freak out on me. I'm going to teach you a quick and easy way to do this. Okay? So that you're not going to have to remember what exponent you're working with. Okay? Because a 192 is 100 plus 90 plus 2. And if I turned it on in zeros, it would be 11 0 0 0 0 0 0. That's its binary for 192. Okay? And the reason why I'm looking over here is I have my cheat sheet up in the corner. Okay? That's the values of each bit in an 8-bit sequence. So 192 would be 128 plus 64. Yep, that adds up to 192. So 11 0 0 0 0 0 0. I don't have the other ones turned on. Okay? Holler at me when you have a question. Okay. Here it is laid out for you. Dotted decimal, 32-bit address. Is this one easier to understand than this one when you first look at it? Okay, it's easier for the computer. This is how it sees it. This is how we see things. Okay? And here is my octet bit values. You'll notice I have those on the board over there. Okay? And it's easy. We start here our most right position with 1. Our next position is 2. Our next one is 4. Our next one is 8. The next one is 16. The next one is 32. The next one is 64. The next one is 128. What did I do moving right to left? I doubled each time. Okay? Does that make sense? Okay. So if you make your grids out, okay, do your 8 bits, and we're going to work on this a little bit on one of the labs. We're going to work on it together. Do your 8 bits across with their value. It makes it easier to go from dotted decimal to binary. It also makes it easier to go from binary to dotted decimal, okay? Because we add or subtract our values depending on which way we're going to work the assignment. Okay? So, if I have turned on. I have 32 turned on. 16, what's that value?
176.
Okay. If I have 128, 64, 32, 16, 8, 4, 2, and 1 turned on, what is it? 255. If all my bits are on, it's 255. You've worked with a few things that have given you a subnet, and you notice they're 255, 255, 255.0. That means that the first 8, 16, 24 bits were turned on. Okay? You have to check my math because it's not always accurate. Okay? We got this? Kinda. Because we'll keep working on it. Trust me. We will work on this a lot. Okay? We convert decimal to binary. You start here, you have a number, 192. We're going to turn on 128. Okay? Because that's our biggest number. You're going to subtract 128 from 192. What do you have left?
64. No.
Yes, 192, take away 128, it's 64.
Yeah.
Yeah. And then what do you turn on?
So then you would turn on the 64.
Uh-huh. And then what do you turn on?
Nothing else.
Nothing else. Okay? If you have 168, we turn on 128. Do we turn on 64?
No.
No.
Why?
Put it
Because
over.
it's more than what's left over.
Because 128 minus 168, it's 168 minus 128 leaves us 40. Okay? So we turn the 0 on for 64. Then we check out 32. Can we turn it on?
Yes.
Yes.
Yes. So 40 minus 32 gives us 8. Can I turn on 16?
No.
Can I turn on 8?
Yes.
Yes. Do I have anything else to turn on?
No.
No.
That's how we go from dotted decimal to binary. And trust me, you're going to get a lot. Okay? Any questions so far? Nope. Okay, you'll notice here we converted the entire IP address from dotted decimal to binary. Okay? So you've got 1 0, 0, 0, 0, 0, 0, 0, and yes, I have to count them on my fingers to make sure I have enough zeros in there. Our next one is 1 0, 1 0, 1 0, 0, 0. Okay? 10 is 0, 0, 0, 0, 1, 0, 1, 0. And the same thing with 10 again. Just because where it's located, which octet it's in, doesn't change how the binary works. Okay? The binary is still the binary for that 8-bit section. Okay? We good? That one doesn't work. This one does. Here. Once we've come up with our IP address, okay, we have network, we have broadcast, we have device. Okay? When we have a 24-bit network, that means that the first 24 bits are for the network. They're all ones. The last 8 bits of that 32-bit address is reserved for our host or for our devices. Okay? And you should be able to determine from an IP address you're given, and if it has /24 on it, you should be able to tell if it is a network address, a broadcast address, or a host address. Okay? Based on where it is. Here's an IP address. 192.168.10.10. My subnet mask tells me that the first 24 are turned on. So I know that this last 8 here are my host address. Okay? So to find the network and host portions of an address, a device uses a separate 32-bit pattern called the subnet mask. Okay? Right now, it is showing you a classful subnet mask. That means we have class A. Class A is an 8-bit network. That means the first 8 bits are turned on for the network. The last 24 bits are turned on for host. Okay? That's a lot of devices. Okay? Those are reserved for like IBM. They grabbed a hold of one of the first ones. Okay? Some of the big corporations. I think the government has an IPv as a
Classic.
class A. Then we have class B. 16 bits are turned on for the network. 16 bits are turned on for the host. Class C, you have 24 turned on for the network and 8 turned on for the host. And then you get to a couple of the smaller ones that aren't used very often. And most of IPv4s, or actually all of IPv4s, have now been used. Okay? Here's what they consider valid subnet mask. Okay? You're not going to have to worry about this so much. I'm going to teach you what's called the magic numbers next week. We might get to it this week. You'll learn how to do magic numbers. You'll write magic numbers in your sleep. Trust me, when I teach this, I'm doing subnetting all night long. Okay? But it depends on which ones are turned on. Okay? As to what your subnet is. Okay? With a subnet mask, you're not going to have a 1 and a 0. It's only going through all the ones. Once the string of ones stop, that's where that subnet mask stops. Okay? That makes sense?
So your subnet mask will always be ones until they stop and everything else is 0.
Correct. Okay. Here you'll notice you have a network address. It tells me that it's 10.1.1.1.0. This tells me it's a 24-bit network, which means the first 24 bits are turned on for the network. They're ones. Okay? My first host address is 10.1.1.1. Okay? This network address we don't use. Okay? It's the networks. Okay? My first host address is the first one that I can assign. Okay? My last host address is the last one I can assign. Okay? I cannot assign the broadcast address. Okay? It's reserved for the broadcast. If you're subnetting and your broadcast comes up as an even number, you've done something wrong. Broadcasts are always odd. Okay? Always. With our IPv4, broadcasts are always odd.
Broad rhymes with odd.
Yep.
There we go.
Okay? So my number of hosts is 2 to the 6th, and we'll go into that a little bit later. Okay? Those 8 bits, it's 2 to the 8. That gives me 256. I have to subtract 2. The network ID, the broadcast ID. So that tells me I have 254 usable hosts. Okay?
That's where I messed up last semester.
Okay? This one is a /25 network. Tells me that the first 25 bits are for my network. Okay? So if I've got 32, 25 of them are for my network, how many's left over for my host?
Take 128 out of
7. Got 8 bits.
it.
I've used the first 24 and one more out of that octet, so I've got 7 host bits left. Okay? So on this one, I still have the first host address, but you'll notice that my IP address is different. Do you see that? It's now at 127, because I can't use 128 because what is it?
That's wrong.
It's already turned
That's
on.
all turned.
Okay? That's part of my subnet. Okay? So I'm using 7 hosts So 2 to the 7th is 128. I subtract 2 from it. What does that leave me?
126.
126 is my host that I can use. Okay? We good? Some of you look a little glazed over.
So what did he say about the 128 is used by the,
128 is the next subnet.
oh,
Okay? I can use, I've got 126 from 126 usable, but 128 total IP addresses. 0 is one of them.
okay,
And then through 127, that's actually 128 addresses. Okay? Because you count 0 as 1. So 127 plus the 0 that equals 1 is 128. Okay? My subnet mask for this one would be 255.255.255.128. Because I've turned on that one network bit. Okay?
Okay, that's what was kind of throwing me off. That's where you get it, it's the subnet.
Yes. Get in front of it, I can't see it. Okay. I'm gonna drop out and show you some other stuff. It's called bitwise and anding. Okay? Bitwise and anding. Oops, if I turn projector on. Okay? Get in the habit of making out your chart. It helps you. Okay? So I've got 128. Uh, 64. Now I'm going backwards. 32.
16, 8,
4,
4,
2,
2, and 1.
Okay? So bitwise and anding operations. I have my IPv4 address and I have my subnet mask. If I only have those two, I can determine what my network address is. Okay? So, let's go to this one. They've already figured out the, there we go. It says 192 is what?
1, 1, and all yours.
1, 1. 168 is
10, 10, 1,
10.
zeros.
and then 10,
Zeros, 0, 0.
3 or 4 of them.
4 zeros. And then 10, 10, 10.
Like 1 0 1 0.
Okay, that's my IPv4 address. In binary. Okay? Then I'm going to take my subnet mask. Okay? And it is 255.255.255.0. If it's 255, that means all my ones are turned on. Okay? Because if you add all that up, it equals to 255. Correct?
Mm-hmm.
Okay? Now, 1 and 1 is 1.
Okay.
1 and 1 is 1. 1 and 0 is
0.
the rest of them are zeros because my subnet mask was all zeros. Okay? So this is a device address. This is my subnet mask. This is the network. 24-bit network based on the subnet mask, okay? Because I have 24 ones turned on, okay? So this is network. This is one of my IP addresses, because I have 254 of them that I can use, okay? Because this is where it begins. That's where it begins. And it's gonna go to okay? This is a 24-bit. Once I turn all of them on, it's 255. This is my net ID. This is my broadcast. Okay? This week and next week, we'll get more into the different topologies. And next week we'll start subnetting. So you'll have that 25-bit network or the 26-bit network. And one of the things I need you to learn how to do is make your chart, because when you come in to take the exam, or anytime you're even working on assignments, you need to make your chart, figure out what your network ID is, your first and last usable, and your broadcast. Okay? Yes?
If you ended up not using all of your IP addresses, would your broadcast still be the same thing, or would it
Yes.
be where you left off?
Your broadcast is always the same, and it's always odd, okay? It marks the end of that network. Whether you use one in that 254, or you use all 254 addresses, okay? It's the beginning and the end of what you can use. And typically, you're not gonna fill up and use all of them in your subnet, because you need room for expansion. Okay, so when you're planning your networks, you take what you have now and you think, am I gonna grow? And factor in, growth. And subnet based off of that. Okay? So one of the charts that I would suggest using, and by the way, I'm gonna send this out as a PDF, all the stuff that I'm scribbling. Okay?
Thank you.
You're welcome. Typically, I'm going to have a network described for you that may have PCs on it. And each of these PCs represent all the PCs. I'm not drawing out all of them. Okay? I didn't have that much time. Okay? But what you need to get in the habit of doing, you're going to have the name of your network, because I'll name them, you'll see that. And then you need to have your net ID. Okay? In this instance, the net ID is 192.168.10.0, because that's where your network begins. Okay? And give yourself room to write, because 32 bits and also in dotted decimal takes up some space, especially some of the people who write big. Okay? Yes.
Question, can we use Excel?
No,
So you don't have to, okay.
no, you cannot. When you come in to take your test, you will show up with a pencil.
Okay.
I give you the paper, I give you the exam. Okay? If you want to use, actually, I'll go ahead and have these devices labeled for you, so you don't even have to come in with the sticky notes to label your devices.
Can we use draft paper?
If I can find some, but probably not.
Okay, so we can't bring our own draft.
You cannot bring anything but your pencil. You can bring in several different color pencils if that helps. I have one lady, she finally got out of the program, but every time she came to take a test, she showed up with like at least 4 colors of pencils and highlighters, so that she could make her notes the way she understood it, and then she would transpose it to my test. I'd always have like 3 or 4 pages of scraps for her. But I knew that's how her brain works it, and you each have to kind of learn your own style, okay? So you got your name of your network, you got your net ID, you're gonna have your first host, you're gonna have your last host, prefix.
The
Okay?
slash.
That's the
24.
slash, whatever that number is. Okay? So we know with this one, okay, we're gonna call this example. Its net ID is 192.168.10.0, correct? We know that it's subnet mask because they gave it to us. It's 255.255.255.0. You also need to put it in dotted decimal on the test. Okay, so that would be 24 ones and 8 zeros. Okay, each of them, each 8 are separated by a dot.
Maybe. Dot
So-
decimal.
So it'd be 1, 2, 3, 4, 5, 6, 7,
Oh.
8 dots.
Okay. That's what you.
Okay? 4, 5, 6, 7, 8.
We have to put both of them.
And then our prefix on this one is a 24. Okay? Because of how many ones do I have turned on?
24.
24. Okay, with a 24-bit network. Okay? The easiest way so you don't have to do your math, because I'm all about doing it the easiest way possible. Okay, my next network, okay, if I were to have another network following the same line of thought with these 24 bits, my next one would be 192.168.11.0. That's 255. Once you hit 255, once you add 1, that's 256. Well, there's not 256 in that 8 bits. So you had to add 1 to the octet before it. Okay? So I know that my broadcast is 1 less than him. Okay? And this comes in handy once we get to like the 25-bit networks. Okay? Because if it's 25 bits, that's a 128. So I know my first one starts at 0, my next one starts at 128, my next one starts at 0 again. Okay, and I'll show you that in a second, how that works. Okay? So my last one that's usable is 192.168.10.254. Because it's 1 less than this one. My first one
And your net
is
ID.
1 more than my net ID. Does that make sense? Are we getting there?
So,
Okay, this is just how to figure out your net ID.
And will we have to do decimal version for each address or just the subnet? Okay.
You may be asked for the dotted decimal. You may be given the dotted decimal and asked for the binary. Okay? You may be asked, is this a network address or a host address? Okay? I've seen all of those in assignments and in quizzes and exams. Okay? Once you have your IP address and your subnet mask, you need to be able to assign it, okay, to your device. Okay? You're going to go for the LAN interfaces in here in these classes. Down here in the bottom, right now it looks like
oh, so-
right now it looks like a little computer. You see that? If it was wireless, it would look like the waves for the wireless setting. Point to it, right click, click Open Network Settings. Okay? That's where your assignments will not work properly, your exam will not work properly. You go into the Ethernet connection, you're gonna go to Properties. You will scroll down till you see IPv4. Select it and go to Properties. In this classroom, as long as you're connected to my network, okay, it is going to be set to obtain and obtain. Okay? For the assignments and labs you do when you're connected to the routers and switches that are here in the center console. Okay? Once you've unplugged from my network and plugged into the routers and switches, you have to be connected here. I'm saying this because it will throw up on you and then they'll yell at IT because I've put people on the network that don't belong. Okay? So keep me out of trouble. Okay? When you come here, you're going to click Use the following IP address. Okay? And this is where you'll use the IP addresses that you came up with. Okay? You'll notice here that it gives the IP address 10.0.0.1. It has the subnet mask, and it has the default gateway. Your default gateway is where it heads from the router. Okay? The router is your default gateway, whichever port it comes in and out of. Okay? On the exam, it'll tell you whether to use the first usable host or the last usable host for your gateway. If you're working on your own network, you're the network administrator, you need to decide, do you want to use your first or your last? You need to determine that so that in your documentation, because you always need to document your networks, how it is that you've determined which one is your default. That way, if you move on to another job, you know, something happens and you no longer work there, whoever takes over that next position, they're not having to try to figure out how your brain works to come up with your addressing scheme.
Is there a preference?
No.
Is it, and it's always either your first or your last, is your default.
No.
Okay.
But, you know, make it simple on yourself.
Yeah.
But generally, you only have one router or one default gateway per network.
No.
No?
Per subnet, but not per network. You could have a network with 15 or 20 routers on it, you know, 40 to 60 switches. So, for that subnet, yes. Not for that network. Think in the big scheme of headaches. Okay? So this is where you would put your IP address, your subnet mask, and your default gateway. Typically, they're not going to have you set a DNS. Okay? Not typically. Okay? Anybody that's running Windows 8.1, if for some reason your wireless stops working, like it was working great and fine, and all of a sudden it stopped, go put 8.8.8.8 in as your DNS, and for some reason it starts working again. That's Google's DNS, so it knows where it's pointing to. It's like it gets lost without one. Okay? Any questions where we are right now? I know this is a lot. You also have to click OK, OK, and OK. I think it's 3 times for it to take that IP address. I've had people say it won't ping, I can't connect to it. Well, they've got the window still open, they never said OK for it to accept it. Okay? So make sure that you at least OK it out of it. You can open it back up. Okay? But make sure you've at least OK'd through it enough to where it's accepted that IP address. Okay? And you can verify that by going to the command prompt and doing an IP config all to make sure you've got the right IP address and subnet mask in. Okay, it'll also show you your gateway. Okay? Any questions? Are we good so far? So far, so good? around, wake up again. When we come back, we'll briefly hit on IPv6 just a little bit, but I want to get in and do one of the labs with you so that we can make sure you understand the bitwise and the anding, because that's one whole assignment. It's nothing but bitwise and anding. Okay? All right. So that you're not panicking from this point out, and then we'll go over a little bit more, and then we'll work on our lab together. Okay? And I'm going to do magic numbers for the 4th octet. Okay? Mainly because that's where you need to focus for the rest of the semester, you know, things coming up at the end. Make sense? Okay. Everything is based off of an exponent of 2. Okay? So, I'm going to write down my 2. Why did I do 8 of them? There's 8 bits. So I've got my exponents. And if you can get in the habit of writing this, and I mean write it a lot, so that when you come in and I hand you a sheet of paper, you can write this down before you do anything else. Okay? You're going to write this down, this one, and then you're also going to write down, go ahead and draw out your chart. Okay? So, here's my 2's all to whatever power they are. Okay? Sometimes I get lost. This is called your magic number. These are our magic numbers. Now, I'm going to subtract 2 from everything. Why do you think I'm doing that? The 2 represents my network ID and my broadcast. So I'm going to subtract that. Okay? So this is my magic number here. Subtracting 2 represents my net ID and my broadcast, because I don't use those 2 numbers I don't assign them to anything, correct? So this number here are my usable hosts. Okay? That's the number of usable hosts I have per network. Does that make sense? You good? Okay. 2 to the first, when I've got that last bit turned on. When I subtract 2 from it, what does it leave me? Okay, it's not a network. Okay, because there's nothing to assign. We don't use it. Okay? This one leaves me 2. This is always your WAN. Because your WAN needs, how many addresses do you think? 2. Okay. You're going to have your net ID, your broadcast, and your 2 usable. Okay? All right. I'm going to start down here at 2 to the 8. Okay? This is a /24-bit network. Okay? Guess what? This one is a /25. numbers, and then we subtracted 2. Start at 24, and we count backwards. Okay. I could have 2 to the 0 up there, that would be a 1, you know. It's still not, there's not even a net or a broadcast in that one, okay? Now, you know our subnet mask says 255, and if we're working in the 4th octet, it's 255, something. Okay? So we have 255, dots. Okay? Right here, it's a dot 0. Because I'm using all 8 of those bits per host. Okay? So there's nothing assigned to my network. Okay? If I'm using 1 out of this one, it is 0 plus my magic number. So this one is dot 128. If it's a /26, that means I have the first 2 ones turned on. So that's going to be my 128 plus 64, 192. And we keep going. 192 plus 32,
224.
24 plus 16, 240 plus 8, 248 plus 4,
252.
these are our magic numbers. And don't worry, I have a video out there for this, or I will. I've already got it recorded. If you go to my YouTube channel, you can already find it. Okay? Do you see where this might come in handy? If you know this much, okay, about those 8 bits, then you're good. Okay? It's going to work the same here. It's going to work the same here as far as figuring out this part of it. Your host, usable host, grows exponentially. Okay? I mean, way. Yeah. Because 2 to the 9th is what? 518, something like that, 528, something like that. So, I mean, it just keeps growing. Okay? Any questions about this? Okay. Let's talk a little bit about our unicast and multicast transmissions. With IPv4 networks, the host can communicate one of 3 different ways. You have unicast, and that's the process of sending a packet from one host to an individual host. Okay? So, 172.16.4.1 wants to send something to 172.16.4.253. Okay? They're all on the same network. So, this 4.1 will send it to the switch and straight on to 253. In this instance, 253 is an IP printer. Okay? It didn't send its print jobs to 4.2 and 4.3 or to the gateway router. Okay? It was a unicast that went from here to there. Uni. Okay? Broadcast. What do you think the broadcast does? Kind of like your broadcast, watch the broadcast news. 255.255.255. That sent it to everybody under the sun. Okay? So everybody received that information. Does that make sense? Multicast. With multicast, it's a process of sending a packet from one host to a select group. Okay? So you have unicast that goes from one to one. Broadcast goes from one to everybody. Multi goes from one to a group. Okay? It does reduce traffic. Unicast and multicast reduces traffic. Okay? Because it's only using those particular IP addresses that it's sending stuff back and forth to. It's reserved for IP for multicast groups are 224.0.0.0 to 239.255.255.255. That's just keep it out there in your brain. You have a link local. That's routing information exchanged by routing protocols. You'll learn more about that in the second 8 weeks. Okay? And globally scoped address is 224.0.1.1 to 238.255.255.255. Okay? Example here is that 224.0.1.1 is reserved for network time protocol. It's NTP. Okay? There are certain blocks of addresses that are public. There are certain blocks of addresses that are private. Hosts that do not require access to the internet can use private addresses. Okay? That's the 10 dot range of the /8, so it's the 10.0.0.0 8-bit network. Anything in those 10s can be considered private. 172.16.0.0 to 172.31.255.255. That's enough of them. Then we got 192.168.0.0 to 192.68.255.255. Okay? And you'll notice in your assignments, a lot of times you're using the 172 and the 198s in here for your labs. Okay? Shared address space addresses are not globally routed. They're intended only for use in the service provider network, and it's the address block of 100.64.0.0. Okay? Commit this to memory for the test for chapter 8. You may not see it again. Okay? But know where you can go back and find it if you need it. Okay? Network broadcast addresses within each network. The first and last address cannot be assigned to host. What did I say about a broadcast address? It is always odd. So if the broadcast is always odd, what do you think the network always is?
Even?
Even. You have a loopback address, and it's a special address that hosts use to direct traffic to themselves. And we'll get more into that later. You have a link local address, and it can be automatically assigned to a local host. And link locals, we'll get into that the next 8 weeks. You have a test net. Those are the ones you use to test your network. Test net, okay? And then you have some experimental addresses that you can use as well. I talked a little bit about classful addressing. We do have D and E. Okay, this one's experimental and that one's multicast. You don't go assigning those typically. Classless addressing is actually called CIDR, classless inter-domain routing. Okay, and you will see CIDR notated in your text and in your labs. Okay. It's created a new set of standards that allow service providers to allocate IPv4 addresses of any address bit boundary or prefix length instead of only using A, B, and C. Okay? Because you might have a class B address assigned to you by your provider. Okay? Well, you don't want your entire network on that B. You might want to chunk it down into smaller networks based on function, location, that type of stuff. be able to subnet it and make it into smaller networks. There are people who assign IP addresses. These are the agencies here that do that, or the major registries for those who do that. Okay. You have 3 tiers of ISPs, that's internet service providers. You have your internet backbone, tier 1, Sprint is one of them. Then you have tier 2, they're generally focused on business customers. And then tier 3 often bundle internet connectivity with other stuff, okay? I'm gonna record you a video for IPv6. Right now, I want us to work on the assignment for IPv4 because I wanna make sure you understand it, okay? If you'll open up NetSpace, you can go ahead and download the assignment. It is the one called Converting IPv4 Addresses to Binary. 8128. Okay? Are we good? Yay, nay?
No.
Are we good? See if I can erase this. Oops, I'm gonna- Okay, first one here, step 1, says convert IP addresses from dotted decimal to binary. It says convert decimal numbers to their binary equivalents. Okay, so I have this chart up. Okay, we've got our 8 bits. Okay, remember it goes 1, 2, 4, 8, 16, 32, 64, 128. Okay? The first number it has done for you is the 192. Okay? The next one we're going to do is 168. Okay? The way we do this is we're going to turn on 128. Subtract it gives us 40. Do I turn on 64? Turn on 32.
Yes.
I'm going to subtract 32. And I turn on 16.
No.
And I turn on 8.
Yes.
And I turn on 4,
No.
2,
No.
1.
No.
Pretty much the only time you have that 1 turned on is with the odd numbers. The only way we're going to get an odd number. Okay? Does that make sense? What's our next number?
10.
10.
Did I turn on 128?
No.
64?
No.
32?
No.
16?
No.
8?
Yes.
4?
No.
2?
Yes.
1?
No.
Okay? Remember I said if we have 255, what's turned on?
Everything.
All of it's turned on. Okay? Because if I add 128, 64, 32, 16, 8, 4, 2, and 1, it equals 255. Okay? And then if my number is 2, operation determine the network address. Okay, this one I'm gonna do in two parts. Okay? I have 192.168.10.10. Didn't we just do that one in the lecture? I think so. Let's drop on down to, let's do A. 172.16.145.229. Do you see that one? Let's do 172. Do I turn on 128?
Yes.
Do I turn on 64?
No.
Do I turn on 32? 172 minus 128. Somebody help me with my math. I think that's right. Turn on my 32. Include the 12. Do I turn on 16?
No.
No.
I turn on 8.
Yes.
I turn on 4.
Yes.
I turn on 2.
No.
I turn on 1.
No.
Okay. My next number is 16. That's easy. I just find 16. And everything else are zeros. And there's certain numbers that you will start picking up on that get repeated a lot. Okay? Like the 192 or the 172s. Okay? Because you use them a lot. So you'll start remembering which ones to turn on for those. Okay, my next number is 145.
Where is this? Where's
Step
Step
2A. You have that one?
you, I
Okay.
think
Yeah, we were, that's like,
Yeah, everyone thought you were doing 172, 16, 18,
Sorry.
183.
Mine says page 3.
yeah, we're on page 2.
Oh, sorry about that.
Sorry. All right,
So we went over part of that already in lecture. 145. Do I turn on 128?
yes.
Do I turn on 64?
No.
Do I turn on 32? Do I turn on 16? Yes. Do I turn on 8? I got this going on out through there. Do I turn on 8?
no.
Do I turn on 4?
No.
Do I turn on 2?
No.
Do I turn on 1?
Yes.
Okay, and my last number is 29. Do I turn on 128,
No.
64, 32, 16,
Yes.
8,
Yes.
4,
No.
2, 1.
Yes.
Okay? Are we good? Okay, I went ahead and figured it.
No, you're supposed to do it for.
4 it is 4.
My bad.
4 needs to come on.
Okay.
We good?
13. Yes.
Okay. So 172 is 10, 10, 11, 0, 0. Yep. 10, 10, 11, 0, 0. So it is 10, 10, 11, 0, 0. Here's my dotted decimal, my dot right there. 16 is 3 zeros, a 1, and 4 zeros. Correct? 145 is 1, 0, 0, right? Good so far? 29, 3 zeros, 3 ones. Yep. That's the IP address I was given. Okay? Subnet mask I was given is 255.255.0.0. Correct? So turn on my ones.
16.
And the rest are zeros, right? I'm gonna figure out my network address by what? I'm gonna do any, okay? So 1 and a 1 is
1.
1 and a 0,
0.
1 and 1, 1 and 0,
0.
1 and 1,
1.
1 and 1,
1.
1 and 0,
0.
1 and 0,
0.
1 and 0.
0.
Sorry.
0. 0. 1. 0. 0. 0. 0. 0. 0. They're all gonna be zeros.
Guess what?
You were doing too much.
I zeroed too much. Too many zeros. See if it'll recover. May not. What does it say?
Covered that.
Yes. Here we go. What was my last octet?
0.
3 zeros, 1 1.
It was half and half.
Right? Okay. I'm gonna cheat a little bit for what? Right there's where my one stop.
Oh. Oh, you mean on
Does
top?
it match up?
Yeah,
There's no more that are gonna match to give me a one. Right? My whole grid. The rest of them are zeros. So what was my first octet's number? What is 128 plus 32 plus 8 plus 4?
172.
172,
16.
16,
0.
and then the rest of those are zeros. Okay, so the network address for that is 172.16.0.0. Do you see where we got that? Kind of. Can we do another one?
What finger you got out? That's the IPv6?
This is 4.
Okay.
10, what do I turn on?
The 2.
I like easy math. One 72.
That's gonna be 1,
10, 10, 11, 0, 0.
And how did we know that so quick?
Because we did it already.
We've done it already. 2.
All zeros, then 10.
Okay. And then we need to figure out 8. That's another one that's fairly easy. Correct? So the 10 in 172 was 10, 10, 11, 0, 0. Is that right? 2. How many zeros do I have first? 6. For the 8, I turn on 4. Okay. That is 10.172.2.8 in binary. Okay? Its subnet mask is 255.224.0.0. So I know that the 255 is all ones, right? Now if I go to my magic numbers that I've written down, and I got 224, how many bits are network bits? You see that? 5. Where are you? We say 5 were network. So that's 128 plus 64 plus 32 plus 16. Right?
Yeah.
Huh? Is that right? Does that make our math right? No. It's 2 to the 3rd. Because 5 of those were hosts, not. That was 2 to the 5th with 2 to the 5 hosts. Okay.
3 ones.
So it's 3, because 5 minus 8 is 3 for the network. 5 were for hosts, 3 were for network. I didn't do that. Alright, so we turn those on. Right? And then the rest are what? Zeros. Now, you can either use anding, if it's easier for you to go 1 and 1 is 1, 0 and 1 is 0, 0 and 0 is 0, or you can look to see where the last set of ones line up. Okay? That would be here. Correct? So, so our network address for this one is going to be 10 dot. What is 101
160?
160?
That's gonna be dot zero, dot zero.
Yeah? Dot zero, dot zero. This prefix is 11. We had 8, 9, 10, 11, ones turned on and it's subnet mask.
So what does that, the first row represent? Is that the IP
This is
address?
the actual IP address you're given.
Okay.
This is the subnet mask you're given. And then this next one here is going to be our network address.
And we put the /11 afterwards.
I put it afterwards because that way you know this is the network and it's an 11-bit network.
And, but are we gonna need to do that like on the exam, whatever? Is that what you're expecting?
I would get in the habit of doing it.
Okay.
So the only thing that's ever ones are the ones and ones.
Correct.
Okay.
How do we get the 11 bit?
We turned, our subnet had 11 ones turned on. Right, those were our network
How
bits.
many ones in the subnet, that's how many bits.
Correct. Are you okay with that? Is it clear as mud?
Mm-hmm.
So that means the 21 zeros represent how many devices? What is that? How do you figure that out again?
Do that.
There's 21 zeros, which means that's how many device, you know,
That's how many hosts.
or yeah,
It's, how many did you say you had?
21.
That would be 2 to the 21st. What is that? Somebody got a calculator? 2 to the 21st is a bunch.
That's
Give me the
two
numbers.
million nine,
That, give me the numbers. 2,
2097152.
minus what?
2.
That's two.
So the usable host on this one so you have 2,097,150 hosts on that network. How manageable is that?
2.
That's easy.
Do you see where you might want to subnet it? Put it in smaller chunks. Makes it easier assigning things if you have it in smaller chunks. Either by geographic location, job function. We'll get into that the second 8 weeks when we start talking about VLANs or virtual local LANs where we can chunk things together. Makes life easier. How are we here? Good, not so good, all right. Have to keep looking at this device to get the real time. in the E portion, online portion of the book, there are a number of hands-on activities. Like here, it gives you an ASCII converter. You can type in a character. And it's gonna give you its binary. Just so that you can understand and see how that works. There's several activities that it lets you key in the number that you think this is. What number do you think they're representing here? 128 zone, 16 zone, 8 zone. What is that?
One 52.
We can see. You can check it. And it tells you if it's correct or not. Very good, Jake. Now you can give me a new number. I know this one, not even by adding them up. If they're all on, it's what?
255.
The only one that's not on is the 1.
It's 254.
So it's 254. Okay? So there's several of these activities in here that are very helpful. It's going to walk you through some of the stuff we've done today. Okay, then it lets you turn on the bits like we've done. There's binary games that you can go play. Okay, here's an example so you can see how those packets that we talked about with the unicast, broadcast, and multicast. If I'm sending that 172.16.4.1 to that printer, this is how you can actually see the traffic flow instead of just looking at arrows on the screen. Here's a limited broadcast. Here's a multicast. Do you see the difference in the multicast and the broadcast? And here the source was 172.16.4.1 and it said it's 255, 255, 255, 255. So everywhere. So we sent it out and it hit the switch, it hit all the devices available, and then it went out to the router. And then the multicast, the source is the 172.16.4.1. It sent out information, but it doesn't go to the router. It only stays within its network. Here's an activity that's going to let you practice. It does time you. For you to determine if the IP address that it gives you here is unicast, broadcast, or multicast, and you do that by clicking on the devices. Okay? So if I start it, it gives me 237, 192, 126, 17. Where's it going to go? Which one is it going to? Tell me.
The group.
Okay? So you just go in and click. When you get it to where you want it, you click stop. You can reset it. It's good so that you can practice and get it in your head. How exactly is this working? Okay? It's a great little activity for you to do there. Here's another one where you're calculating the network and the broadcast and the first and last usable. Remember we talked about public and private? Here you can go in and try to see which ones are what, just drag and drop wherever you want to. I'm not paying attention, I'm just dragging and dropping at the moment. You can check it and see what's right and what's wrong. Okay? Do you see where that would be beneficial? Alright. It is 11:46. Do you want to keep going with the IPv6 or do you want to work on some of your labs and see why I'm available if you have questions? What do you want to do? Because this is supposed to be part of your lab time too. 6.
Yeah, 'cause, yeah.
Okay, IPv6 network addresses. IPv6 is designed to be the successor to IPv4. We figured IPv4 would be around forever, but we've run out of addresses. Okay? The depletion of the IPv4 address has motivated us to go to IPv6. I know Robert said on one of the assignments he was doing this weekend, he had to go in and turn off IPv6 so it would work, correct? Because his router and stuff was looking for IPv6 because it assumes that we've already gone to it. Projections showed that all 5 will run out of, and the RIRs are the ones who give out the IP addresses. IPv4's address between 2015 and 2020. If I'm not mistaken, I heard that that last one's already been given out. Okay, so I think we've already hit that portion here in 2015. With an increasing internet population and limited IPv4 address space, issues with natting and the Internet of Things, we have to move to 6. Some people have already done that. Some people are just now getting there. Okay? IPv4 has a maximum of 4.3 billion addresses, and we've run out of them. Okay? IPv6 has a 128-bit address, so that leaves us with 340 undecillion, there you go, addresses. That's a bunch. Okay? IPv6 fixes the limitations of IPv4 and include additional enhancements such as ICMP version 6. And that'll make more sense next semester.